I'm Anton, and I'm a climatologist, and chances are you might be too. Climatologists sit at the intersection of business and nature. They want to play a key role in minimising the human-led impact on the environment, but they also understand the realities of living and working in a modern, capitalist world. In this series, I'll be proving that climatologists are already out there leading the charge to marry their own good businesses with sustainable climate principles.
Ever wondered how steel is made? Well, Google's got you covered there. But here's what I want you to focus on. Steel production uses coke, not the soft drink, but a fuel derived from coal to remove oxygen from iron ore. It might sound technical, but here's the thing. Every ton of steel burns through almost 700 kilograms of coal. And since we make 2 billion tons of steel a year, you guessed it, that's a lot of CO2 pumped into the atmosphere. Enter John Mellowes and his company BioCarbon. They've come up with a sustainable workaround to producing steel using Biochar instead of coke. What's Biochar? Think sustainable charcoal. It's made from plants, not fossil fuels. So it only recycles existing carbon instead of adding new emissions to the atmosphere. The result is cleaner steel without compromising on performance. And here's the thing, it's not just good for the planet, it's a smart business move too. Steel companies are chasing solutions like this because decarbonisation is no longer just a nice to have, it's a must. With a $20 to $40 billion market opportunity on the line, John's company is leading the charge and potentially making a big profit on the way. So, if you're interested in learning more about the science and business behind sustainable steel, stay tuned for my chat with John.
We'll get straight into it, John. You started your professional career as a civil engineer, but today you're spearheading innovation in the green steel sector. Before we dive into BioCarbon's work, can you share a bit about your background and what ignited your passion for this sector, for climate change, for decarbonisation?
Yeah, okay, so I've done a variety of things. As a civil engineer, I basically ended up being a project manager. I worked for McDonald's, I worked on the M4 motorway, I built mobile phone infrastructure, and then ended up in my own manufacturing business. And my best friend and twice best man, Chad Shepherd, had just sold his business.
Twice?
Yeah. That
story for another day.
Well, yeah, I've been his best man twice and he's been mine twice. So it is a story for another day. So he just sold his business and I said, and mine was running quite sweetly, and I said, we should do something together. And he said, I'm interested in alternative energy. So we looked around and came across pyrolysis, and we thought, that's good. Gas is, the gas produced from pyrolysis is obviously going to be handy. Did some more research, and we came across the biochar movement, if you want to call it that, and also the wood vinegar, which is another product of pyrolysis. And we actually got into it in the early days for the wood vinegar, to produce wood vinegar. Then that all sort of rolled along, and we were selling a little bit of wood vinegar, and we had someone supplying it to us. We were helping them to develop their technology, and then we sort of went separate ways from them and ended up with our own technology.
Can I interrupt you for a sec? So, there's heaps to unpack there.
Yeah.
Zooming out for a sec, decarbonisation in general. What's the appeal of that?
Look, well, I get there's the obvious, which is, as a species, we're going to have to fix this problem, and I think plenty of people talked about that. So I don't see there's much for me to go into there. I'm motivated pretty much the same as everyone else. It's obviously a problem, and we've obviously got to fix it. Having said that, it provides tremendous opportunities in this change for people to do things, to innovate, to create new things, to create new businesses. And that's really what we've done.
So the scale of the opportunity.
Yeah. And I mean, we're dipping our toe in sort of renewable carbon, which we'll obviously talk about, but energy and the chemistry that uses fossil fuels, that's all going to need to be changed. And there's a lot of opportunity there.
So you started this business, 10, almost 15 years ago. How has the landscape shifted between now and then in terms of the scale and the types of businesses that are coming up?
Well, for us in particular, in about the last 2 years, the steel industry is really getting very serious about decarbonising. Probably driven by Europe, but also around the world, everyone sees, okay,
This is happening.
we can stop playing politics. This is happening, and we're all going to have to deal with it. And so that's fed into a great opportunity for us.
So let's turn to the landscape and provide some context for our listeners. The steel industry is a major emitter, responsible for approximately 7 to 9% of global CO2, which is madness.
Yep.
Can you explain the role of coke and coal in traditional steel production and some of the hurdles that you've had to overcome in introducing biochar?
Yeah. Okay. So there's let's say 3 ways of making steel. 2 of them use iron ore. What iron ore basically is iron and oxygen. It's basically rust. And you need to get that oxygen off the iron atom. You need to break that bond. So you heat it up and you've hopefully got some carbon in there. And that carbon then grabs that oxygen molecule and heads off as a gas. First is carbon monoxide, and then maybe further along the chain it'll grab another oxygen and make carbon dioxide, possibly. So steel, the majority of the steel in the world is made using the blast furnace method. And so that uses a lot of coal. So to make a ton of steel, you need about 700 kilograms of coal.
Wow.
We make about 2 billion tons of steel a year. So everyone can do the maths. It's a hell of a lot of coal that's getting burnt to make steel. Now, the next way of making steel from iron ore is that you use, as they call it, direct reduced iron. You make direct reduced iron. So you have the iron ore, you heat it up again, and at present you use natural gas to strip the oxygen off the iron ore. This is in terms of greenhouse gases, this is a much more friendly way of making iron from iron ore, because when you use hydrogen, which is on the methane, on the natural gas, you make the byproduct is water. And while water is a greenhouse gas, most of it sits in the ocean, so it's not so much of a problem. And you do make a bit of carbon dioxide, but there's a lot less carbon dioxide. Now, the third way to make steel is using what they call an electric arc furnace. The electric arc furnace takes iron, pig iron, or whatever you've got, hot briquetted iron, but they're all technical terms that people probably don't want to know about, or scrap steel, and you basically put it in a big bucket and run a lot of electricity through it to make it hot, and hey presto, you've made steel. In that process, though, you do need a little bit of coke or carbon just to keep that atmosphere from oxidising some of that steel. So in that process, for your tonne of steel, you're only using about 15 kilograms of coke. So there's a lot less there, but it's still an issue. One thing to note is that the electric arc furnace is used primarily in countries that have a well-developed steel industry, because generally you need the scrap coming back into the system to make the steel. So, for example, the United States uses 70% electric arc furnace. China uses about 10% electric arc furnace, simply because there's just not a lot of scrap floating around China, because they've only developed really in the last 20 years, right? So they're not knocking down buildings yet. They're not scrapping cars. They're not all of that stuff.
Gotcha.
Yeah.
So we expect that ratio to shift as they as their market sort of matures,
yes,
and they get enough steel stuff in the economy.
And the Chinese, being who they are, have said we're going to move our electric arc furnace production from 10% to 15%. I think it's by 2030. And if their performance around renewable energy is anything to go by, they'll probably beat that.
John, let's break down this concept of pyrolysis. What is it, and why is it more sustainable than burning coal?
So it is the heating of, in our case, biomass without oxygen. And what happens then is that biomass breaks down into charcoal and a lot of water, actually, and also the syngas. It's a very simple process. It's been around for a long, long time. Prior to the oil industry kicking off, it was the primary source of a lot of industrial chemicals.
Interesting. Okay. And so byproducts are char. You said water is syngas. One of the things that we talked about when I went out to the site the other day was wood vinegar.
Yes.
What is wood vinegar?
Okay, the water is basically the wood vinegar. So the wood vinegar is about 85% water. Then you also have a bunch of other chemicals in there, primarily acetic acid and phenols. And then there's a whole lot of other bits and pieces. And what we do with the wood vinegar, we're selling it to agriculture, and it's a microbial stimulant. Plants actually exude a lot of the chemicals that are in the wood vinegar, and they do that to get the microbes stimulated to give them back
The things that
nutrients that they need. Yeah.
Oh, that's fascinating. Okay, so why is biochar, this additive into the steel process, more sustainable than using coke and coal? We'll break down how it's used in a second.
Yeah, sure. So obviously, coke is made from coal, not the kind that you drink, obviously, but it's made from coal. And whenever we burn coal, we're adding extra carbon dioxide to the atmosphere. Because we're making our version of coke, what we call green char carbon, from trees, a sustainable source that actually pull, obviously, carbon dioxide out of the atmosphere, all we're doing is cycling the existing carbon dioxide that's on the surface of the planet, if you like. So it goes from atmosphere to tree to our green char carbon, and then in the steel process, it goes back into the atmosphere.
So it's a cycle, a closed loop.
It is closed loop, yep.
Gotcha. Whereas when we're pulling stuff out of the ground, we're reintroducing stuff that's been buried for hundreds of millions of years.
That's right. So I always kind of think of it, I'm sitting in the bath and I've got a couple of cups. When I'm making green char carbon, I'm just tipping water from one cup to the other. When I'm burning coal or coke, I'm putting a new cup of water into the bath, and sooner or later it's going to overflow and make a mess in my bathroom.
Got it. That's a brilliant explanation. And in terms of replacing coke and coal with biochar, is it just a like-for-like transfer? Are there other risks in introducing it into the process?
Chemically speaking, the biochar is actually better than the coke. Coke is made from coal, and coal's been squashed together over a gazillion years, and that means that there are other elements in there that aren't really useful in the process. So these are, when you burn the coal, they're ash. They turn to ash. And so obviously you don't want ash in the process, because you have to get it out of the steel for one thing, and it steals heat from you because you have to heat the ash, and you just don't want to waste that heat. So charcoal, like the charcoal we make, is 95% fixed carbon. There's a couple of percent ash, and then the rest is what they call volatiles, which has still got carbon in it, but is not fixed carbon. It's not stable carbon. So we've got 95% fixed carbon. Our chemistry is great, but we need to make it into a product that's usable in the arc furnace or in any industrial setting, really. And so that needs to be handleable. Charcoal, as most people will know, you can crush it in your hands. It gets very dusty. These are problems that industry just doesn't sort of need. So we basically we do some treatments to give it that mechanical strength and a density that's more useful in the furnace, and then we've got a product for the steel industry, and we can, even with all that work, we can make that product at a comparable price to coke.
That's impressive. So I guess just to break it down a little bit, what we're saying is coal that stayed under pressure has been mineralized somewhat, through the process of sitting under the ground.
Yeah.
And those are those extra things that the industry sort of relies on coke and coal having in the process.
Yeah.
What you're producing through your process is really simple, pure, chemically straightforward.
Yeah.
And you're actually having to add back some of that, recreate that mineralization process.
We add some stuff back in that we wish we didn't have to, and from a chemical point of view, a chemistry point of view, just to give the green char carbon, that strength and durability for the industrial process. Yeah. So I mean, if we had the choice and we could just make a product that was 95% fixed carbon, that's what we do. But we need to give it some strength and stuff. So we have to add some bits and pieces back just to give it those properties
to make it more useful. Let's chat about. So you mentioned cost parity. Let's chat about cost parity. Why is that important in this process?
Well, obviously, this is an industrial process, and the steel industry. There's a lot of overcapacity in the steel industry at the moment. So the steel industry is working hard on its margins. It's a tough business. So cost parity is absolutely necessary. They need it.
What percentage of the margin would coke and coal represent of the input costs?
It wouldn't be much in an electric arc furnace situation, but it all counts. Those guys, most small business owners would shudder if they looked at a steel business because the margins are low, the capital costs are extremely high. You have loads of employees. It's a tough business. It really is. So if you're, they are looking around for the 0.1% to save money on.
In terms of so overall decarbonisation of steel, so obviously coke and coal is a component. What are the other major components of the stack to decarbonise steel, make a green steel? Okay,
so in the electric arc furnace, there's this little bit of coke that we give them. The big energy input is electricity, and so that is going to need green electricity. So these guys are all moving to power purchase agreements with various energy suppliers to sort of start transitioning to green electricity.
And the coke and coal component is probably the hard to abate component.
It is, yeah. So if you talk about scope 1, 2 and 3, obviously electricity is not scope 1, so they can buy the right electricity and that's good. But in terms of scope 1, their carbon use is about 45% of the total emissions.
Got it. And that's that. So scope 1 being the emissions direct from their operations.
Yeah, that's right.
So let's talk about market size then in that context. What's the size of the market? How do you think it's going to shift?
Well, it's big. The non-blast furnace coke use, I think, is about 100 million tonnes a year, and I think that adds up to somewhere $20 to $40 billion a year.
Wow, that's a big market.
It is.
In startup land, that would be huge.
And of course we're not going to get every cent of that, but we're going to try and get a good chunk of it. Someone has to.
And you think that whole market of coke and coal will be replaced with biochar or some other component?
It'll have to, or they'll have to find another way to refine those minerals because this market isn't just steel. There's also titanium and all sorts of other minerals that like ferroalloys that get made using coke.
So I come from a software background where things move pretty quickly. We can be pretty nimble. 0 to 100 in a couple of years. In industrial process, it seems to be there's a longer process. You start with an idea, you move to a pilot stage, demonstration stage, and then into production.
Yep.
What are you learning at each stage? Like, what are you learning in a pilot? What do you learn when you get to a demo?
Yeah, well, look, it's mostly technical stuff. So all that stuff I went through before, how do you handle wood chips, all that sort of stuff. In a way, going from a pilot to the next step, I don't expect we're going to learn a hell of a lot in that technical way. I think really it's a demonstration for others. Sure, we'll learn things, and there'll be hiccups along the way. There always are. It's engineering. That's the way it is. But really, it's about demonstrating to investors and customers that the thing can operate, can work, can do what we say it's going to do on a commercial basis. So we'll produce the product for the same price as coke. That's really what the next phase for us is beyond, and we're at sort of pilot plant stage now.
So for context, how much bigger is a demonstration plant than a pilot plant?
It's about 20 times.
20 times bigger.
Yeah. In engineering, it's not, you're not going from a plank across a creek to building the harbour bridge. It's very doable. All the principles are the same. It's not that big a deal. We're not in sort of mega project scale here. We're not building a nuclear power station or anything like that. This is certainly within reach.
And scale from demo to production, like what would that look like?
Oh, that's pretty much the same scale.
Same scale.
Yeah.
Right, interesting. So you don't. So your demo plant is the same as your production.
Is production plant. Yeah.
Would that be the same for other sectors?
I'm not sure. I guess it depends on the opportunities they have. I'm sure most people would go from a pilot plant to full scale production if they had the backing to do so.
Got it. In terms of customers, so one of the things that also sort of surprised me was customers. You don't have any customers actually using this in anger for large scale steel manufacturing. How does that? Is that something you're de-risking at the demonstration phase?
Yeah, for sure. So we've made we've made tens of tons of product. We've done trials in the electric arc furnaces in Newcastle and Sydney, and they've come off really well. We've made 3,000 tonnes of steel. That's enough for three 25-storey high-rises, three of these that we're sitting in. And so that has de-risked a certain amount. And in fact, one of our trial partners is now joining with us to move this thing ahead.
Let's go back a couple of years, and there was a moment you told me that you threw out an existing methodology entirely.
Yep.
So you'd been in the business for almost 10, 12 years.
Yeah, point. We had been fiddling around for a good while. Yeah.
And what happened?
Well, this was a machine that we built based on someone else's philosophy, basically under license, and we worked with it for 1 or 2 years, I guess. And we came to the realisation that it could not progress. And in particular, it had a lot of problems. This is where we learned a lot about handling wood chip in hot areas, hot zones. And in particular, we realised that we could not scale that particular plant. So without being able to get to the scale that we're about to do now, you can't make the charcoal economically, and so you don't have a business.
Was that so? How did you get to the point of like, okay, how much was it worth, this plant that you were throwing at?
Well, depending on who you ask, it was probably $500,000, something like that.
How do you make the decision to throw away 2 years of research and $500,000?
Yeah, well, sometimes it's just obvious, and you can't avoid the truth. We couldn't sort of put our head in the sand and think it was going to work, because it wasn't. So we just had to make the decision to move in a different direction.
So you basically...
I should say $500,000, but there was a lot of ancillary equipment to that we kept for the next plant. So it's probably, $500,000. It's a good story. It sounds nice and dramatic, but it's probably not as bad as that.
But it did involve a big pivot in terms of how you were approaching things.
Yes, absolutely.
And how did you arrive at the alternative approach?
Research. Good old University of Google, really. Like and in particular, my best mate Chad, he did a lot of work and came up with the idea.
And how's it gone over the last couple of years since that shift?
Well, brilliantly, to be perfectly honest. You saw it yesterday. The thing runs itself just about.
It was beautiful.
Yeah. We've run it for long runs, 100 hours sort of thing. We've done, I think it's about 1,500 hours total on that machine now. And it was something that we did as a sort of quick proof of concept that we threw together. And we thought, we'll let this thing go for 6 months and then we'll, go and build something bigger. And it's still going. Probably 2 years later.
It's incredible. And something that struck me when we were speaking yesterday was you said at one stage you had 7 people kind of trying to hold the thing together to get it to work.
The first machine, yeah.
So the next machine, it runs tickety-boo.
Yeah. So, and that's that's one of those. So you have the tough day when you say, let's throw this thing away. And then you commit to building this other thing, and like you're Elon Musk with that third rocket launch or whatever, it's got to work. And we turned it on and it started running, and we all kind of said, okay, yep, there's 7 or 8 of us standing around. What do we do now? And it's literally been like that from day one. We've had, of course, we've had little problems here and there that we've had to fix, but it's a completely different experience, completely different.
So that research and development or refinement process, how does it so you guys are effectively competing with the likes of BHP and producing something like this? Like, what does innovation look like in your organisation versus one of those larger businesses? So
our sort of practice of innovation goes like I said, then someone comes up with an idea and sort of we all talk about it and being competitive, we're all trying to knock each other's other ideas down and and so there's this kind of friendly Shark Tank kind of thing, where we're trying to poke holes in it. And if we can't poke holes in it, then we'll generally go away and do it. So that's kind of what we do. We also, nobody's, there's not too many egos there, so that's pretty handy. And when we're going to try something, we're trying it because there's going to be a benefit. So we all actually want it to work. So that's very helpful, because then when if you get these little issues that sometimes might look like the thing's no good or it's not going to work, well, then you've still got those 7 or 8 heads in there thinking, oh no, what if we do this or what if we try that? So yeah, that's how we work anyway.
Got it. And on an efficiency basis, how efficient do you think you are compared to a different player or larger player?
Miles in front. Because look, I often joke that we're a bunch of guys, tinkering around in a shed, and we are, and that means we're highly skilled and we can connect motors to things and control them with computers and all this sort of fancy stuff. But because we're running things tightly and we don't expect to have a gold-plated whatever to do the job. We can make things work, and if we need, we've got equipment there, we can go and make something up to get us moving and over the line to prove the concept, and we're off. Whereas bigger organisations, they're kind of siloed. They have the engineers in one office and the research guys in the other, and then they have the tradesmen over here, and they kind of speak every now and then. Well, we're all those things together all at once, and everything's flying around in quite a chaotic, in ways, manner, but it works.
It sounds like things progress quite quickly in that environment.
They do. Yeah, they do. Of course they do.
Yeah, the Shark Tank, the idea Shark Tank sounds a little intimidating. But you guys are lovely humans.
But, you met us yesterday. We're all mates. So, sometimes when those ideas come up and we shoot each other down, it's with love and humour, you know what I mean? Like when Clive was giving answers and I said, oh, mate, you've been in the chair 10 minutes and you're already telling us what to do.
I love that, yeah. All giving all the secrets away too.
Yeah.
So something that's come up a lot in conversations for me in the climate space broadly is the funding gap. And you talked about learning about funding, specifically in the industrial transition, and also how challenging it is to get early customers, right? Because it's kind of an all or nothing thing. So let's break that down. So customers, partnerships and funding. How did you go about getting your first customer?
Well, we did trials with them. So it was that simple. We did trials and they said, this is really good. What are your plans? And we talked from there. So finding customers has not been our problem.
Interesting. So how did you get in front of this customer in particular?
Because we knew a couple of people in the steel industry. Yeah. And once we got that foot in the door, it was a fairly easy sell, to be honest, because like all good products, it sells itself.
especially if it's cost competitive.
Cost competitive, yeah. Yep.
Brilliant.
Well,
Okay.
when you put in, if we're getting carbon credits, you're ahead of the game.
So we talked about as well a broker and a potential financier that has come on as a partner. How did you get in touch with those people?
They found us actually. Yeah. So we're not firmed up on that yet. We're still talking with various people, but yeah, finance is not our game, but we're learning rapidly. Yeah. So that's an ongoing watch this space kind of.
And how do they find you? How do they come across you?
Well, stuff like this. To be honest, we've done a fair bit of not a fair bit. We've done a little bit of media, and we've won a grant where politicians came, and we made a couple of industry mags because of that, and it kind of starts to snowball.
Mm. So let's talk about funding then. How are you assembling funding for your project?
Okay, so we've got our steel partner who they're proposing to be in for a quarter. We've got another a large commodities trading house. They're proposing to be in for a quarter, and they found us again through that sort of industry mag partnership that I read. And then the last half, we're talking to government at various levels, various departments about grant funding. After this next project that we're currently planning, we'd like to think we can use different levels of funding, a bit more debt, because the equipment will be proven, and we'll also have a cash flow that the lender can look at. So that's what we're expecting to do next. A bit more debt, and also, then we'll be a bit more attractive to infrastructure type investors as well.
Sounds a bit like herding cats.
It is. And actually, I blame you guys. It's the software people, because the investment, the VC kind of industry, if you like, is used to very quick turnarounds, and quick failures and quick wins. And we come along and say, okay, we're going to have all this capital equipment. It's going to take us a year and a half to put it all together before you'll see any return. And they look at us like, what are you guys, from Mars or something? And then we say, yeah, but this is industry, and we're not going to decarbonise industry without some industry.
I guess the size of the prize is pretty interesting as well, right? You're talking $20 to $40 billion annual market size.
Yeah.
And is there, do you, like, to your knowledge, is there anyone looking at something similar that can do cost competitive Coke and Cola alternative?
There are people who are fiddling around for sure, but none of them are at our price level. There's a mob in England who I think are doing it, but the prices that they're talking are way above us, like orders of magnitude kind of thing, an order of magnitude.
So it's kind of I guess it's almost an all or nothing thing, right? If you're successful in proving this out, then you're ready to scale. Yeah,
that's right. And then at that stage, we really see that the challenges for us will be the transitioning from a very small business to possibly quite a large business, and quite rapidly. So that's going to be tricky, and that's going to be something that we're going to need to really focus on, because we're all small business people, so that'll be challenging. Of course, capital to fund all this equipment will be interesting, but hopefully some of our bigger partners will be keen on doing that. And that's about it.
So let's talk about geography. So your potential target markets are vast. Obviously here in Australia, Asia, North America, Europe. How do you choose which market? And is Australia the right place to start?
Australia probably isn't the right place to start, to be honest.
Brutal truth.
Yeah. We're not in the middle of Australia makes 0.3% of the world's steel, so it's not a big user. But we've been lucky in that the steel makers here are progressive, and they are thinking about decarbonisation. It's really on their radar. They want to do something about it. So we haven't had to move yet. I do expect that we will be expanding. We've got to build these plants overseas. There's no doubt about it to service the mills that are there.
And which market would you focus on first, do you think?
Okay, so let's start with Europe. They've got a pretty strong carbon price. They've now got their carbon border adjustment mechanism. So that will be one place, obviously, to go. And they produce 50-60% of their steel in electric arc furnaces. So I think that's a pretty strong starting point. There's also North America produces a lot of its steel in arc furnaces, 70%, and they have a lot of biomass too. So that also could be interesting, although the push to decarbonise there is probably a few years behind the Europeans. So that's a bit tricky. China, I think, and Japan, Korea, China definitely will be a place that will have to be because they make half the world's steel. So, even though they only make 10% of their steel in electric arc furnaces, they're still the biggest electric arc furnace producer in the world.
Wow.
So we'll have to be there. And yeah.
Because if you lay the right foundations, then you kind of set yourself up, and it's been a long experience.
Yeah, we need to make ourselves like the McDonald's of charcoal making or something, where you can plonk a McDonald's anywhere in the world.
There's your elevator pitch. We're the McDonald's of charcoal making. Lift and shift the model. Makes a ton of sense. Yeah. That's brilliant. Well, I mean, there's your background, flowing through. You mentioned you worked at McDonald's.
That's right.
Here you are, sort of scaling a process. Yeah. How amazing is that?
But we do need, we need that kind of repeatable formula, so we can go to places and go, okay, this is what we do. Bang, bang, bang. Let's make that sausage again over there.
So you talked about, let's talk about, focus. So something that came up yesterday a bit was all of the other different uses. So we talked about agriculture for biochar.
Yep.
You mentioned already, other metals that rely on coking coal. How did you decide on the right direction, and maybe give us a little hint of a flavour of some of the other uses of biochar?
Yeah. Okay. So biochar, we originally we're thinking agriculture would be the place for it, because obviously if you take that charcoal and you stick it in the ground, you lock up that carbon forever. Biochar originally got discovered because there's some places in the Amazon where the Indians had mixed charcoal with their soil, and it's still there, and it's still the most productive soil in the Amazon.
Wow.
Yeah. So we were primarily focused on agriculture, and then we sort of said, okay, to sell this to the farmers at the price that they want to pay, we need to get to scale. But we can't find any farmers who are going to give us an offtake agreement for the scale that we need to get to. So we kind of then looked around and said, well, who can? And that's when we started talking to the steel industry. But biochar in agriculture will definitely be a big deal. One, for the decarbonisation or the carbon drawdown effect. So you lock up that carbon in the ground. It's almost the reverse of burning coal. But then it also has a great effect on the soil. So that, the productivity of the soil improves.
Why is that?
Well, if you look at charcoal under an electron microscope or something, it's got all these little holes in it. It's very porous. So when you put that in the ground, and the moisture, the microbes and the nutrients can all go and sit in there, and the plant can come and pull it off as it needs it, rather than if you've got a sandy soil, for example, you can put the nutrients on, you can put the water on it, and it'll drain through and leach away. Whereas charcoal will hold on to that stuff. So it improves the surface area of the soil, basically.
And for a plant, that means
that it holds those nutrients and moisture and the microbes that do all the work of converting nutrients into something the plant needs. They're all sitting there for the plant.
So you just got a richer base of soil.
Yeah. So you can see where biochar's been used. Sometimes you can pull the plant out, and the roots are wrapped around little bits of biochar.
Wow! So it makes soil more productive.
Yep.
And we're burying carbon for good.
That's right. Yep.
Amazing, but limited, based on limited capacity at least on the distribution.
Yeah, that's right. So at the moment, like it's fairly well known that this can work, but people aren't. We're not getting to scale yet to really run it out there for agriculture. We certainly would like to do that, and it's still on our radar, but we've got to kind of get our technology proven at scale and over the line before we can attract enough people to start building these plants dedicated for agriculture.
For alternative purposes. Is it hard to focus? Has it been hard to focus?
Yes, very. Yeah, I mean, there's more rabbit holes in this than I've ever seen in my life. Like, there are so many opportunities and things opening up that, yeah, we do have to kind of sometimes say, no, let's just ignore that because we can't service it.
And how have you developed that discipline?
By making mistakes, by chasing things, and then you get too much on your plate and you say, okay, I'm failing everyone here, so I've got to decide to cut a couple of things and service the people that I know I need to service right now. And those opportunities, they're not gone, but they're gone for now.
Wow, I mean, coming back 20-40 billion, it's a big pie to be chasing. So.
Yeah, and that doesn't talk about agriculture. So we don't really know what the agriculture market is.
Gotcha. What opportunity do you think is being left on the table in climate?
Oh, I don't know. Do you know, I'm not sure there are many, because now that I'm in this space and talking to guys like you and going to, Climate Action Week in Sydney and things like that, you meet a lot of people and there's a lot of stuff being done. And really, I don't look around and think, oh God, we're not doing that. Why aren't we doing that? There's a lot being done. That's why I'm very, I believe we're going to beat this thing, and we'll beat it relatively quickly. I think in 10 years' time, we're going to say, I think we've got this licked. And then in 10 years after that, we'll say, what were you so worried about? Like, I'm that kind of guy, but I look around, I see all these smart people, industrious people coming up with these brilliant ideas, and I think, wow, we'll get this done easy.
Maybe funding might be, if I had to volunteer something. Lots of smart, clever people, but needing funds to get it.
Funds, but look, funds will follow. I'm a great believer in our system, in the economics of the free market, and I think the people who've got the money at the moment are probably a bit tentative about giving it to people like me, but I think before too long there'll be a few big
standout successes,
and they'll think, we've got to point ourselves in this direction. Or we spoke yesterday, a lot of VCs are focused in and around software, and that's fine. Software's great, and it's going to do a lot for us. It is doing a lot for us, but they've got that sort of paradigm, and that needs to be broken. But it will be, because they'll see that there's money to be made, and the first person that jumps will make more than the others, and that's how our system works.
FOMO is a big driver of action.
Yeah.
And finally, any advice for others thinking of taking the leap to start a business to address climate?
Look, you're going to have good days and bad days. It's a third. Some days are bad, some days are good, and some days are okay. If you get too many bad days, maybe it's time to reassess, but generally you'll probably find the goods and the okays will outdo the bads, and if that's the case, just keep going. And, people say it so much, it's almost getting boring now, but don't be afraid to fail. You're going to stuff some stuff up. I mean, you don't want to obviously go out intentionally to fail, but the amount of stuff we've screwed up is just epic. I mean, we could do this whole podcast on what we've got wrong. That's just the way it is. You've just got to know when you have and turn the ship around and do something better.
Make big calls, and it sounds like you've made a few.
Yeah, well, you have to.
Brilliant. Well, John, thank you very much for being on the show.
No worries. Thanks for having me.
Once again, if you like listening today, then please subscribe to The Climatalist wherever you get your podcasts, and give us a follow on Instagram, where we're just Climatalist. I'm Anton. Thanks for listening.